Who remembers learning about pH in like junior high? Good. And you would have learned that there's a scale, right? And the pH scale goes from 1 to 14. Did you learn that? Good. And if it's underneath, or if it's 7, it is neutral. And an example of something neutral was water. Good. And if it's less than 7, it is an acid. Good. And I would hope that you learnt that acids are sour in their taste. For example, some real-life acids, lemons and vinegar, are sour when you taste them. So other things like ketchup is sour when you taste it because of the vinegar, and then they sweeten it with lots and lots of sugar. So you're eating sugared vinegar with a wee bit of tomatoes in ketchup. Acids are corrosive. What does corrosive mean?
Eats through our place.
It eats through things, right? It's like it burns it, but when I say burn, I don't mean a flame, but you still get that burn hole. Like, you know when a spark has hit your shirt or whatever, and you get that burn hole in the spark? That's what a corrosive spot looks like. So as a chemist, I have lots of clothes that have little corrosive circle holes in lots of different things that I've had to throw out. Okay, because I haven't worn my lab coat on that day. So if you spill battery acid, like has anybody kind of opened something up and the battery has kind of leaked a little bit and it's all crusty? Have you seen that? Right? That's the battery acid corroding things that it's touching. Like the plastic casing, like the metal connection spot, like, okay? So metals are corrosive. And certainly, you know, an ulcer in your stomach or an ulcer in your esophagus lining is a corrosion that's often caused by an overproduction of stomach acid. So you have a perfect amount of stomach acid in your body, but if you get indigestion, it's when the stomach acid kind of bubbles into the esophagus, and it doesn't feel so good because that's not supposed to be acidic, it's supposed to be neutral in that tube. Right? You know when you throw up and you get that burn, right, on that spot there? That's the acid that's come up and it's burning your tube. It is corroding your lining of your esophagus. That's what ulcers are often, you know, always and often in your digestive system. And certainly that's what that feeling is after you have thrown up. And you know that feeling on your teeth as well? You know that feeling I'm talking about? That's the acid on your teeth. So you brush your teeth, which is a base. So it neutralizes that acid and makes it all nice and clean. And if you suffer from indigestion a lot, you would then eat some Tums, which is also an alkali that neutralizes that pathway then for you as well. Everybody get it? Okay. And lucky for you, that pathway regenerates itself on a regular basis. So for every bit you corrode, it just replaces very quickly. So it's not like you're in massive damage unless you're bulimic and you do it often, and then you've got issues with corrosion because all the acid in there all the time. Okay, so corrosive, we understand now. Arrhenius was a scientist that did a lot of work on acids, and he's the one that told us, look, acids contain H+. So HCl must be an acid. H2SO4 must be an acid. HNO3 must be an acid. And I've written all these ionization equations down for you. Or one that cropped up today was HBr, and we decided that that was an acid because it was H something or other. Everybody okay with that? And acids ionize in solution. Spencer and Emilio. Spencer, you should be writing on your paper and your paper only.
Yeah.
Thank you. So then they had to do this modified theory, because did you notice in Science 10, when you were, in Science 10, when you were drawing the Bohr diagram of hydrogen, you went like this. Hydrogen, how many protons? Look up the atomic number, 1 proton, because the atomic number of hydrogen is 1. Right? How many neutrons? The mass minus the number. So 1 minus 1 is 0, so 0 neutrons. Must have 1 electron because they're balanced, 1 and 1. And then electrons on the outside, so 1 electron. Everybody okay with this Bohr diagram of H atom? H plus then must have lost that outer electron because it's got 1 extra proton. Then, so here you go, 1 proton, 0 neutrons, and that outside shell is empty. So what is H plus? What is H plus? Just a, yeah, it's an ion.
Proton.
It's just a proton. See that? H plus only has a proton. Doesn't have any neutrons, doesn't have any electrons, just a proton. H plus is just a proton. How stable is just a proton floating around in your solution going to be? The answer is not stable. So what it does is it has a piggyback ride on the water. So here you go. The H plus actually bonds with your water. And I've drawn water here. Because remember these lovely lone pairs on oxygen that push those bonds down and make it V-shaped? Remember those lone pairs? They're big clouds of electrons, right? Big cloud of negative charge. There's one big cloud of negative charge, there's another big cloud of negative charge. That proton swimming by sees that negative charge, goes, hello, nurse, and is attracted to it. So here it is. There's the H plus attracted to that lone pair. It's a shared pair of electrons, but both of them came from oxygen. See that? Shared pair of electrons, but both of them came from oxygen. And so I can draw a stick, just like we did in our bonding unit. There's a stick for that shared pair. There's a stick for the original hydrogens. And so I get this H3O plus, because it's still an extra proton in the whole system. So this is an H3O plus, which is called hydroxonium ion. Do you know those times I've told you it's H plus? I've really simplified it. It actually isn't H plus at all. It's hydroxonium ion, H3O plus, which is just water and an H plus together, H3O positive charged. Are you okay with that? Okay, you should be highlighting, underlining, and annotating your note package as you go along, not just staring at the board. Thank you. Any questions on that? Everybody got it? What's it called? Good. Okay, so bases. Bases, as you probably learned in junior high, have a pH of greater than 7. They are slippery. For example, soap is often basic. Toothpaste is basic. Sodium like a baking soda solution is basic. They leave like a soapy, slippery film on your hands. And they are, you can identify if it's a base because it has an OH minus, a hydroxide. So like sodium hydroxide, potassium hydroxide, calcium hydroxide, all of which are bases. Everybody okay with that? Okay, so what is pH? Because you know it's a scale from 1 to 14, but what do those numbers mean? Where did they even come from? So pH is a calculation of H plus ions in solution. How many H plus ions have I got in the solution? That's the pH. And now you know about concentration. I can actually teach you about the numbers about pH. Okay, because you know about concentration now. So I'm asking you, how concentrated is that lemon solution? If it has a pH of 3, how concentrated of H plus ions are in there? Does that make sense? That's what you're after here. So the higher the H plus concentration, the lower the pH. See how that's a bit opposite to what you would think. The more acidy bits, it has a low pH. pH of 1, really acidic, right? So it must have a lot of these. Even though it's a low pH, a lot of these. Okay? pH of 6 is for an acid, a high pH. So therefore it must have a really tiny bit of H plus, not a lot of it, because it's just a weak acid. Everybody understand that? Okay. I'm now going to teach you this fancy new button on your calculator. Okay? it says log. Can you find it? It should be beside the 7. It should be beside the 7. And it is not a log as in a tree trunk, okay? It is short for logarithm, and you'll learn a lot about logarithms in grade 12 and exactly what they are. I don't really want to get into the mathematical, graphical analysis of logarithms. I'll leave that for your grade 12 teacher. I just want you to use but, okay? So, what it means actually, and you'll notice in blue above your log button is 10 to the power of x. You see that? Log is the opposite of 10 to the power of x. Just like multiplication is the opposite of division, addition is the opposite of subtraction, log is the opposite of 10 to the power of something. Okay? Did you hear that? So, how to find pH is equal to -1 times that log button of the concentration of hydrogen that you're talking about. And therefore the opposite, like as if I were to divide both sides by log, if I wanted to solve for this and I had this, I'd have to, kind of divide both sides by log so the log cancels out. But log isn't a multiplication. So I don't divide, I have to do the opposite of log, which is, what did we just say? 10 to the power of x. So I have to take 10 to the power of x of both sides. So that leaves us with this formula here. The concentration of hydrogen is equal to 10 to the power of negative pH. Okay? So there are two formulas so far, one of which is pH equals negative log concentration of hydrogen, and the second is this one. And I'm loving seeing the annotations of you guys boxing those in too. That's perfect. Oh, yes, one more new thing. These square brackets around a compound is like a chemistry short way of saying concentration of. Okay, so the square brackets mean concentration. It like is a moles per liter. The same N equals C times V concentration that we used before. Okay, so let's just figure out what this means in terms of our button calculator. Okay? So if we have a pH of 3, the question would be, what is the, actually I'll just not confuse the issue. What is the H plus concentration if you have a pH of 3? Okay, so think about this. Is this a strong acid, a weak acid, or basically, it's, kind of a strong acid? It's kind of a strong acid, okay? It's pretty strong. So I should have quite a bit of H plus concentration in there. Everybody okay with that? Okay, so I told you the formula was this. So we're going to use that formula. Concentration of H plus is equal to 10 to the power of negative pH, so therefore -3. Everybody hear that? So grab your calculators, go second log, and you should have this appear. 10, that thing, bracket. Everybody okay with that? Everybody get there? So that means to the power of, and I'm going to put in the number -3. -3. You can close the bracket if you fancy. Enter, and you get 0.001. Everybody okay with that? Okay, hold on. Calculator's kind of off. Logical hats on. Did you already know that? 1 times 10 to the power of -3 in scientific notation is this number. Right? Move the decimal place over 3 times. 1, 2, 3. So this is 10 to the power of -3. Everybody okay with that? 001, 001. Okay, so it makes sense to us. So try this one in your calculator and see if you get this. Do it in your calculator, because then you know how to do it on your own. Got it? Did you get it? No problems in the calculators? Everybody's okay? 9?
Mine just says 1e minus 6.
Okay, so, and did you do it exactly like I said? Second log?
Yeah.
And you
Mine
have
says
1e? Okay, so 1e negative 6 means 1 times 10 to the power of negative 6. Okay, so that means you then have to know your scientific notation and move the decimal place over.
In scientific notation.
You can change the mode for you yourself in there. I can help you with that later. Okay? I'll try to figure it out. I mean, don't know it all by heart. Okay, let's try this log button then. Like not the inverse log, but rather log. If the hydrogen concentration is 0.0001 moles per liter, that should say, what is the pH? So pH equals negative log 0.0001, right? I just put that number in there. Try it on your calculator. Did you get 4? Because would this be 10 to the power of negative 4? Yeah. Okay. Everybody okay with that? So let's just try one. That's not a nice easy multiple for us. What if the hydrogen ion concentration was 0.013 moles per liter? What is the pH? What do? pH equals negative log hydrogen concentration, which equals negative log 0.013. Pardon? 1.88. Everybody see how I knew that was going to be close to 2, Tristan?
Yep.
Everybody see how I knew that was going to be close to 2? Because 0.01 would be 10 to the power of negative 2. Okay. Did everybody punch in the calculator? Did everybody get that answer? At the back? Okay. You need to bring your own calculator to class, Spencer. I say that to you at least.
It's honestly in my bag.
Good. Okay. So, I want you to understand what a weak acid and strong acid is. So look, just go back to these numbers here. pH of 3, you said, was fairly strong, right? pH of 6 is a weak acid. Look at these numbers. See how the weak acid has a much smaller amount of H plus in there? See that? The weaker acid has a smaller concentration. Look at that. Okay, this is what a weak acid and a strong acid looks like in terms of in your beaker. In your strong acid, they fully ionize. So your HCl goes to H plus and Cl minus, just like we thought it would. Look at that. And look in the solution. I see lots of waters here, and I see an X minus for like Cl minus, H2SO4 2 minus, Br minus, and X plus and H pluses. Look at that. So it's all H plus or X minus. Compare that to a weak acid. In a weak acid, they only part ionize or partially ionize. So your vinegar, which is a weak acid, because we can eat it, so it must be weak, only 1% of it ionizes into the two ions. And 99% of it stays together in a molecular compound. So in my drawing here, I have stay together, stay together, stay together, stay together, separate, separate. Did you get that? Okay. So why is the pH so small? Because I have very little H pluses in my solution. Compared to this one, I'll have a lot more. And that's why even if I dilute a strong acid, it still stays within pH 1, 2, or 3. No matter how dilute it is, it still stays within pH 1, 2, or 3. Because I've got loads of H pluses in there, because they all ionized. Okay? Okay, so note water partially ionizes as well. So a little teeny tiny bit of water dissociates into H plus and OH minus. So guess what? Even in a basic solution, I still have a teeny tiny bit of H plus from the water. And in an acidic solution, I still have a teeny tiny bit of OH minus from the water. Okay? Which leads us into answering a few more questions rather than just pH and hydrogen ion concentration. I could ask you, what's the hydroxide ion concentration? Okay, so here's its third formula for us. The third formula is hydrogen ion concentration and hydroxide ion concentration will equal 1 times 10 to the power of negative 14. Do you know where the 14 comes from? pH scale to 14. Okay? pH scale to 14. The bell doesn't ring till 2 o'clock. I'm not sure why there's so much outside, but we still have 10 minutes. Is that right? What time is the bell ring? We're at town hall, so it's 1:50. And that gives us 1 minute. Okay, so we'll leave it there, and we'll continue the rest of this page tomorrow.